Okay, today our lesson is on parent functions and transformations. So our objective in this lesson is going to be to identify the families of functions, describe the transformations of the parent functions, and describe combinations of transformations. Okay, so first we need to talk about this idea of parent functions. Functions can actually be grouped into what we call families based on characteristics that they share. Okay, and what we call the parent function is the most basic function in that family that all the rest of them are related to, hence the whole related parent-child relationship, okay, in functions. Okay, so today we're going to learn about 4 function families. Okay, and we're going to be looking at the parent of that function family, and then we're going to be doing stuff to that parent to get some of the children, okay, to get some of the other functions in that family. Okay, so our first function family is the constant function. What the constant function does is no matter what you put in, you get the same thing out. The parent for that is the function f of x equals 1. So no matter what you put into this, if you put in a 4, you get out a 1. If you have an input of 5, you get out a 1. When you put in a 7, you get out a 1. Okay, so any function in which you always get the same number out is a constant one. Its parent is f of x equals 1. Okay, here's what the graph of a constant function would look like. It's a straight horizontal line. In this case, this horizontal line goes through all the y values of 1. Okay. The domain, again, the domain is all the numbers you can put in. They're the numbers you can put into the function. The range is all of the numbers you get out of the function. So in the domain here, I can put any number I want into this function, but I'm only going to get out the number 1. Okay, so that's my range. Okay, so that's my constant function family. Okay, we have our linear function family. This we spend a lot of time with the linear function family in Algebra 1. Okay. The linear function family, its parent, the most basic, is f of x equals x. Okay, so this line has a slope of 1, right? If we think of our y equals mx plus b, and a y-intercept of 0. Okay, so again, in this function family, when I put in a 5, I get out a 5. When I put in a 7, I get out a 7, so forth. But this is the parent of our linear function family. Every other line is related to this line. This is our parent. The domain, the numbers I can put in, I can put any number I want in, and I'll get any number out. So we'd say all real numbers are our domain, and all real numbers are our range. Okay. Now we have our absolute value family. In the absolute value family, the parent is f of x equals the absolute value of x. Okay. So how this works, again, absolute value is just a number's distance from 0. So when I put in a 5, I would get out a 5. When I put in a 7, I get out a 7, but when I put in a negative 8, we get out an 8, positive 8. So the graph of this function looks like this. Okay. And its domain is all real numbers because I can put anything in. But the range for this is only numbers greater than or equal to 0. Those are only the numbers I can get out, because I can't ever get a negative out of this particular parent. There are some absolute value children that you can get a negative out. So there are functions with absolute value you can get negatives out, but the parent does not. Okay, and then we have our quadratic. We're going to spend a lot of time with this quadratic function here in Algebra 2. But the quadratic family, its parent is just f of x equals x squared. Okay, its graph looks like that. Its domain is all real numbers, but its range, in this case, the only y's I get out are y's that are positive 0. I'll never get a y down here for this particular parent quadratic function. Okay, so what we need to do now for this example 1 is it's asking us to identify the function family to which f belongs. Which family does it belong to? Does it belong to the constant family, the linear family, the absolute value family, or the quadratic family? Those are the only 4 families we know right now. We'll learn of others later. And then we want to compare the graph of f to the graph of its parent. How does it compare? Is it the same as his parent? Is it wider? Is it up more? Is it down more? So forth. So let's look at this function. First of all, which of these graphs, we're given the graph, but then we're also given the equation, f of x equals 2, the absolute value of x plus 1. It has that absolute value in it. Its function looks a lot like the absolute value function, so it belongs to the absolute value family. Okay, so identify the function family to which f belongs. We did. This belongs to the absolute value family. Compare the graph of f to the graph of its parent function. So how does the parent compare to this one? Well, first off, I can tell this goes through 0, 0. This goes through 0, 1. This one's up higher. So it's moved up, and it looks skinnier because this one's quite a bit wider. So it's moved up and skinnier. Okay, so we'll say moved up and skinnier than its parent. We'll have, by the end of the lesson, we'll have some better words for these, more than moved up and skinnier, okay? But we'll get there. Okay, so now that we know what the parents look like, and we know our 4 families, now we're going to be doing some things. We're going to be transforming it. A transformation pretty much just changes the size, shape, position, or orientation of a graph. Okay, so anytime we make a graph, we take the parent and make it bigger, or we take the parent and shift it up or shift it down, or flip it over or reflect it over, or anytime we do any of that type of stuff, we're doing a transformation. Okay, today we're going to talk about 3 different types of transformations. So these are all different kinds of transformations. The first one we're going to talk about is a translation, or back in our elementary days, this would have been referred to as a slide. A translation just moves your function one way or the other. Okay, so a translation is a slide, or we say it shifts the graph horizontally and or vertically. Okay, again, horizontally is this way, left, right, vertically is up and down. Okay, so that's what a translation does. So that's our first type of shift. So let's go ahead and let's flip over. Let's do an example with a translation. It says graph g of x equals x minus 4 and its parent function, then describe the transformation. Okay. First of all, we're going to need a ruler or some straight edge if we're going to be graphing. Okay. So first of all, what's its parent? Who is its parent function? Well, if we look, it's got an x in it, but it doesn't have an absolute value. It doesn't have an x squared. So I'm thinking its parent function, let's see, if we look back at our parents, it's not a constant, it's not an absolute value, it's not quadratic, so I'm thinking it's probably going to be linear. So I'm thinking its parent function is f of x equals x. Okay, so let's go ahead and let's graph that parent. Let's graph the parent first. All right, so there we've graphed its parent function. So now let's graph that function itself. And some of you might be like, well, I'm not quite sure how to graph that. The old standby is to go ahead and just create a table of values. Okay, so x is my input, g of x is my output. Let's put some stuff in here. Okay, let's start with a 0. 0 is nice to put in. When I put a 0 in this function, 0 minus 4 is negative 4. When you put in a 1, 1 minus 4 is negative 3. When I put in a 2, 2 minus 4 is negative 2. Let's put a negative in. When I put in a negative 1, there's negative 5. Let's put in a 4. 4 minus 4 is 0. Okay, so let's go ahead and let's plot those points. We got 0, 0, negative 4, 1, negative 1, 2, 3, 2, negative 2, negative 1, negative 1, 2, 3, 4, 5, and 1, 2, 3, 4, 0. So again, it looks like our line. We're going to have a line that goes like this. Okay, so we should probably identify, this is my g of x, and this is the parent, f of x equals x. Okay, and then describe the transformation. So what's happening from this blue line to the pink line? Okay, well, it looks like I'm translated, so it's sliding it, and I see it as a slide down, 1, 2, 3, 4, but some others might see it as a slide to the right. 1, 2, 3, wait, oh, I went too far on that one, it should be here. That's why my line doesn't look right. There we go. Scratch that, that doesn't belong there. Okay. Okay, 1, 2, 3, 4. Okay, so describe the transformation. Well, it's a translation, and depending on how you see this one, I'm going to say it's a translation 4 units down, because that's how I see it. If you see it as a translation of 4 units to the right, then that's what you would put. Okay. All right, so those are our translations. So let's go back and let's talk about the other type of transformations. The next type of transformation is a reflection. A reflection, or a flip, as it's called, a reflection does, it flips a graph over a line. And this line is called the line of reflection. Okay. So basically it takes the whole graph, just takes like this, and then it just, like, if this is my line, it's just going to flip it over that line. Okay. So, for example, here, let's get my protractor out. This is my figure. This is my line. It's just going to flip it down over that line. Okay. And we did do quite a few reflections in geometry. We're now just going to look at what it looks like with functions in the algebra sense. Okay, so let's go ahead and let's do example 3. So here's the graph, p of x equals negative x squared, and its parent function. Then describe the transformation. Well, first, we should be able to easily identify its parent is our quadratic, x squared. Okay, and so the graph of our quadratic, well, when I put in a 0, we get 0. When we put in a 1, we get 1. Put in a 2, we get 4. Put in a negative 1, we get 1. Negative 2, we get 4. Okay, so based, and we could go look on the front page and see what the parent looks like. The parent is going to look like that. Okay. Okay, now let's go ahead and let's graph the function itself. Again, all else fails, create a table. Okay, so when I put in a 1, I want the negative of 1 squared. Okay, be very careful. This is the negative of 1 squared. This does not mean negative x squared. If they wanted that, they'd put it in parentheses. The squared is only on the x. It's a very, very common mistake. So I would need to take the negative of 1 squared. Well, 1 squared is 1, so the negative of that is negative 1. When we put in a 2, 2 squared is 4, the negative of that is negative 4. When we put in a 0, 0 squared is 0, the negative of that is 0. So, when I go to graph this child of the parent, we would still have the point 0, 0, but then we'd have the point 1, negative 1, 2, negative 1, 2, 3, 4. So when I put in a negative 1, I'm going to get negative 1, because negative 1 squared is 1, make it negative. And then, so what this one is doing is it is taking this function and moving it down here. So again, it flipped it down. It reflected it down. So when we need to describe this transformation, it's a reflection, but we need to describe reflection over what? What am I flipping over? What's the line that it's flipping over? Well, looks like this line right here, right? Flips over that line, here to there. So what's the name of this line? That is called the x-axis. Reflection over the x-axis. Okay. Our very last transformation, which is one of the harder ones to get, is a vertical stretch or a vertical shrink. Okay? This is where it squishes it up and down. Up and down is vertical, right? So this is what I call a squish or a stretch or a shrink, up and down. Okay, so how this happens is when you multiply a function, okay, by a constant. So how you get this is when you multiply a function, multiply by a constant. It's going to okay, sorry, I'm back. So you need to multiply by a constant out in front of the function. It's going to either stretch it vertically or it's going to shrink it. Okay, so and we'll actually look in class on which way we think that's going to go, as far as when is it a stretch, when is it a shrink. Okay, so what I'd like you to do is I would like you to turn to the your turn problems at the back of these notes. We're going to look at examples 4 and 5 in class. We'll have a brief discussion on those. What I want you to do is I want you to attempt the your turn problems 1 through 5. And I just realized 3 and 4 don't actually have functions there for you. So I'll write them in. Oh, I don't know what happened there. So here, let's write them in. The function for 3 is h of x equals the absolute value of x minus 3 in absolute value. Okay. And number 4 is g of x equals 4 times x to the second. Oh, sorry, I can't see that. G of x equals 4 times x to the second. Those are the functions for both 3 and 4. So you need to graph the function and its parent function, then describe the transformation. Okay. All right, and I'd like you to attempt number 5. Look at the domain and range idea from the first page, but we will discuss, so I want you to write something down, but we will discuss that in class tomorrow.